Hi guys, welcome to the Advanced Refrigeration Training Podcast. I'm your host, Kevin Compass, along with my partner, Brett Wetzel. Today's episode is sponsored by Westermeyer Industries, the leaders in oil management and pressure vessels for the commercial refrigeration industry. Whether you're involved with designing a system or tasked with servicing one, Westermeyer Industries has been helping meet the needs of customers like you for the past 20 years. They offer a broad catalog of stock system components with an in-house team of engineers to assist with custom solutions as well. From oil separators and heat exchangers to system monitoring devices, Westermeyer Industries are a total system specialist with industry expertise, engineering know-how, and the manufacturing muscle to help you tackle problems and deliver solutions.
All right, guys. Welcome and good evening. You're here with Advanced Refrigeration Podcast. We're with you, the host, Brett Wetzel, Kevin Compass, and we have a special guest of Adam Chapman from Westermeyer Industries.
Thanks for having me, guys.
Not a problem.
Anytime.
So we're going to go over some things. First things first, we're going to show you guys how to size the separator. We've come across a couple different instances where we've had issues with separators being oversized due to, usually over remodels, they end up taking some load off and putting it on a different rack, or, they just change how many BTUs they're actually adding onto the rack. So Adam's going to go through and actually show you guys how to size a separator up using the application on Westermeyer's website.
Appreciate it. So what I'm going to do first is I'm going to go through and I'm going to put in on this calculator on our website, and you can do the same thing. We have a quick select app that's both for iOS and Android now. So first thing is, if you want to, as Brett and I know Kevin's mentioned several times, if you want to help cover yourself on the lower end range of a centrifugal separator, whereas you want to try to protect yourself on the during low load conditions during the winter months. Part of what we've done is we've developed a rule of thumb that you can operate the centrifugal separators or the helical style, if that's the terminology that you use. And you can operate those in a sense where you're going to generate a little bit of pressure drop on the fully loaded conditions, which is, we all know, is very minimal. But what you do is you cover yourself, like I said, on the winter months and the low load conditions. So when you go to our website, you can go to calculators here and then oil separator, and accumulator sizing. So first you want to do the supermarket application, and it tells you here kind of what that looks like or what this means for supermarket applications where unloading occurs often. And what we'll do is we'll go through and we'll select, so let's say 448A. And for number of suction groups, so this is talking about the number of evaporating suction temperature groups that you're going to have. So we'll do a single suction group to make it simple. Condensing temperature, we'll do 100 degrees. And for your evaporating temperature, and like Brett and Kevin mentioned in their terminology podcast, your evaporating temperatures or your saturated suction temperature, your SST, this is where we're going to put this here. So we'll do a minus 20. And we'll do 250,000 BTUs. Now, again, you'll have to be able to get that schedule off of your rack to ensure that you're getting the proper BTU load and not just looking at what the compressor is capable of running. You're going to want to look at your compressor capacity and your evaporators to ensure you're putting in the right numbers here.
But Adam, I have a quick question for you.
Sure.
So if you let's just say your load is 250,000 BTUs, would you pad that at all to accommodate for the compressor being able to do, let's just say the compressor's able to do 300,000 BTUs. Would you pad that a little bit to make sure that, you have availability there?
I think that if you anticipate that maybe you could have an expansion on a system, if it's a developed store, I think you're going to run the risk of really increasing your pressure drop when you're looking at, because we're talking about centrifugals. For coalescing, you probably could pad that because you'll have a little wider range of operating conditions that a coalescing can operate with. But a centrifugal, you just got to be careful padding that too much, because you will generate a little higher pressure drop than maybe what you intended. But run it at 250, run it at 300, because what we're going to do is we're going to show you here the calculated discharge CFM, because with those conditions, we're getting the mass flow calculation here, and your discharge CFM, or as we call it, DCFM for simplicity, this is what your separator or what the system is running at those conditions. And then if you look here, these are the types of separators that you can use within that range. So if you look at this, so this is a high pressure oil system centrifugal separator with the reservoir built into it. And this is an OS6-15 RES. RES is reservoir, 15 is 1 5/8, 6 is the diameter, and OS is oil separator. So if you look at that, that's an 1 5/8 oil separator. That likely would have been probably an 1 1/8. I'm sorry, 2 1/8 separator, whereas this one's dropping it down to 1 5. So again, there's a multitude of separators. There's other centrifugals. If you got a low pressure oil management system, this model here that's got the float on the bottom. So these are kind of some of the things that are calculator displays and also our app displays. And then you can scroll down here, and then there's a couple coalescing models. And then you also have the options for accumulators as well, because what we do also with those numbers is we also calculate the suction CFM, which is listed here. So there's a handful of models, and I'll just run through them real quick. The A10, so accumulators A, 10 is diameter, 25 is connection. So 10 with 3 1/8, 12 with 3 1/8, 14 with 4 1/8. And so accumulators have a lot more wiggle room on the connection size that you can operate with. It really has to do with the holding capacity that you have desirable there. So really, again, what we try to encourage people to do when they're sizing these is, one, understand your system. We all understand that coalescing provides a much wider range of operating conditions. It also keeps your system clean, but there's costs associated with that. You have to go in and change the filter periodically if you have a dirty system, and another big thing that you're going to have to monitor is your pressure drop. When we're looking at pressure drop associated with a coalescing separator, it's going to be much higher than a centrifugal, even if you are undersizing it a bit. You can have filter failures if you're not careful, especially, again, if it's a dirty system. Centrifugals are pretty low maintenance. There's nothing to fail. It's just you can get some debris if it's a low pressure oil system. You can get debris that clogs up the filter, like Brett and Kevin mentioned in their last podcast, and how to service those. But the reality is the coalescing does feel like a good safety blanket, but a centrifugals, as long as they're sized properly, are good up to 99% effective. I think another thing that we also should probably bring up in this is, when you're monitoring oil and you're trying to identify, I'm tripping on low oil, some of the things that we talk about. And again, I'm going to kind of sound like a broken record, because Kevin and Brett have already touched on a lot of this stuff over the course of the handful of podcasts they've done. But some of the things that we're going to talk about, if you call us and say, listen, I'm tripping on low oil, I'm having some issues, a couple of things. So first thing we're going to say is, give us the conditions, and we're going to size it, make sure it's sized properly. Another thing we're going to do is, does this happen during part load or fully loaded conditions? What does the oil return line feel like? And I know Kevin mentioned this before. So hot, you tend to indicate that you could have discharge gas blowing through that oil return line. Cold means that you probably don't have much oil, or if any oil, passing through that oil return line. So definitely keep that in mind. And then warm is really, as long as you can hold your hand on it and it's not hard to hold your hand on the oil return line, then you've got a decent amount of oil through there. It surprises me that there's systems out there that don't have oil return sight glasses, but those happen. So that's a good rule of thumb. Some of the other questions we're going to ask is, do you see oil return come back after defrost? What that tells us is your separator's not separating, and it is going out throughout the system. And when you go through a defrost cycle and that oil does come back, that is an indicator. And typically that happens during or when you're using centrifugal separators. So those are some of the things that we're going to ask about. those are some of the things that I think our engineering team and myself are going to check with everybody. And sometimes you need to give us a call back. And I just encourage you to utilize us if you do need some troubleshooting tips for that.
Now, you said before about putting in one suction group. I'm assuming that it's going to change the discharge CFM when we do that, right? So if we have a split header and we have one that's -20 and we have one that's, +16 or +13 or whatever, what's that really going to do to the size of the separator at that point?
I think what I can do is I can run through a selection here real quick, but inherently, I mean, you're going to see, depending on the size of the BTU loads that you're putting in here. So, do like a -20 and like a +20. Does that feel good to you guys? And I'll do like 75,000 for this. So you can look here. So we actually list, here's your suction 1 and 2. Here's your total, which was about 325,000 BTUs, which is not far off of what we just did on the other one. It's really not going to change your discharge CFM that drastically because we were running, +20 on one where we got 2 suction groups, and it really lands on the same model. Now, granted, we didn't do in this particular case, we didn't do the supermarket application. So it's, because it's on the line, that probably would have still landed on that 1.5" oil separator. So it just kind of depends on how big each section group is to determine how that's going to really affect your the size of the separator.
Now, Adam, can you go over exactly what discharge CFM is and kind of like a brief thing on how to calculate it?
Sure. So, and in fact, what I can do, if you look at, we've got a tool here on our website. It's just Discharge CFM chart. And this is just going to kind of go through but basically Discharge CFM is the mass flow that we're calculating based on your conditions that you're providing to us. And we come up with a number that based on that refrigerant. And each refrigerant's got its own mass flow properties. So if you look here, to find this, you basically take the appropriate evaporating and condensing temperatures, and you multiply the value by the system tonnage at those operating conditions. Use this value to select the oil separator nearest to the maximum DCFM range. And so we go through here, and you've got R134A at a 20-ton system at a +20 saturated suction temperature at 110 degree saturated condensing temperature. This is your, it comes out to 1.02 DCFM, but you need to calculate your total DCFM for that. So then you need to take that times the tonnage rating, which comes out to 20.40. So you can kind of go through, we have charts for a handful of refrigerants. It really needs to be scrubbed and added, but again, that's what the calculator's for, to help with that, to do that kind of on the fly. Which on our quick select calculator on our app, there's a whole refrigerant slide rule. So if you're in a rack room and you're trying to come up with conditions and you're trying to brainstorm a little bit, there is that slide rule as well to help with that.
Is there also one for suction CFM too, or is it only discharge CFM?
It literally, I mean, so you mean for this this sizing chart that we have here?
Yeah.
Yeah. So there's just one for the discharge, but this principle is relatively the same. But really, you just need to be able to come up with your conditions, and you can back into your suction CFM. But again, what I would recommend doing is just allowing the calculators to do it for you. That way, you feel confident in that.
One thing I was wondering if you could go through and elaborate on is basically, we've touched on it a little bit. Basically, the amount of separation that a centrifugal will actually do when you're not putting through the full CFM. So, like if you're doing 75% of what the rated CFM, and how efficient is that oil separator, a centrifugal one, at that point?
So we rate the centrifugal separators down to 30% of the maximum rating on that we list for that separator. Now, again, that number shifts if you're trying to apply it at a supermarket type application where you're oversizing it. But inherently, we don't want to drop any further below 30% of the max rating, or your efficiencies are going to drop. But as long as it's within that range, we anticipate that separator is going to be 99% effective.
I had an instance, and I called you about this, where basically, I think I was the full CFM, the discharge CFM of that separator, I believe, was rated for 33 CFM, and with having the one compressor on and the one digital on, I think I was doing 9 discharge CFM, and
right.
It wasn't separating anything, and like I said before, the way I proved that was basically shut off the rack, basically pump down the rack for a little bit, let all the cases warm up, and then turn everything on, and then with all the compressors on, then basically I was separating oil. Before I wasn't even doing that before.
Right. So I think that there's, as you guys have mentioned, there's a multitude of scenarios where you create problems with centrifugal separators, and even coalescing for that matter. Coalescing isn't flawless in that sense, but one thing that you guys touched on the last podcast that I think is so important is talking about your oil regulators or your oil pots, whatever term everybody wants to use in that sense. But with these adjustables, set them and don't touch them. If you got oil management problems, start at the separator, watch your oil return line, and then work your way from there. Because if oil is leaving that separator, it's not the separator's fault. And I hear all the time where guys will call me and say, I'm tripping on low oil. I'm like, all right, well, how much do you have any oil in the reservoir? Well, yeah, I've got 2 glasses. I'm like, yeah, we're not there. That oil is going through the discharge line, getting separated, and going back, and it's getting stored in the reservoir. So we've got another problem. And that, the vent valve analysis, and I thought that was excellent. If anybody missed that, and that whole process that you guys determined how to verify whether it was a problem or not, I've never heard that before, and I found that very informative on how you guys work through to ensure you knew whether or not that vent valve needed to be changed or not.
Yeah, it works out pretty good. Yeah, I tend to agree. Guys start messing with floats, it just ends up messing up everything.
Like we said before, there's certain compressors that, they're a little bit more susceptible to a high oil level. And then you have, compressors like Bitzers and Carlisle where anything more than what their max is, and you'll end up, majorly damaging valves and pistons and everything else with them. So it's very crucial that we have a proper oil level in all of our compressors to make sure that we don't have any damage.
Right. And I think another thing that, we're talking about determining coalescing and where the benefits are. And one thing I also want to bring up is, there's a differential pressure monitor that we're launching. And I know some of us have to go in and fight stores because we're under a service contract and it's ours and it's our baby and we're stuck with it. Or we've got these where a guy, you get called in and the previous guy was just throwing wrenches at stuff and, breaking things off. And what I want to mention is this is the benefit of monitoring pressure drop. And it's not about really energy consumption. That's a big deal. But that's not the fight that you guys really have to carry. And you can tell me if I'm wrong. But the big thing is knowing when that filter needs to be changed. And I find that there's a lot of coalescing filters that are dropped in and never seen again until there's a massive failure, and then you've got a really big mess on your hands. So I just encourage everybody to consider this, and whether it's the new one or the existing one. And I have my opinions, and Kevin, I know you have your opinions about the the existing differential pressure monitor. And let's face it, we see that all the time where people talk about how they've never actually seen it in alarm mode. But the importance of this is to know what's going on in the separator. That filter should be designed to seal, and then that differential pressure monitor should be designed to tell you what's going on in the separator, so then you know when that filter needs to be changed. So it's not at 2 o'clock in the morning, and you could have done that maybe on a Thursday at noon when you were in there, and you could have headed off that problem well in advance, or your buddy that is on call didn't just get completely blasted by a problem that could have been prevented. So I think preventative maintenance and on a multitude of products on the oil management system is a very important piece of that. And I encourage everybody to consider that whenever they're looking at some of these jobs.
No, I mean, I put that Delta P in that you sent me, or I'm not exactly sure what you guys, or is that what you guys are calling it?
Yep. It's called the RDP, Refrishield, and that's the differential pressure monitor. Yep.
I mean, that thing worked great. It was easy to set up. I mean, it took no time at all. I mean, it worked great. And I've done the same with 2 transistors before, but you get the drift and it never reads properly. It's a lot more difficult to set up than the RDP. I mean, it did work good. I mean, it should be on every separator. I mean, I like it a lot better than the old style, that's for sure.
Well, the big thing is it provides a constant output voltage, as opposed to the current one where it's just basically you're not getting an alarm unless you're at over 12 psi differential. So this is going to allow you to even plot it out on an E2 or a Danfoss controller, where you're going to be able to see let's say you were trending at 10 or 11 psi differential, and then all of a sudden it's dropped now down to 2, and you haven't done anything with the separator. Well, you may have just had a failure, whether it's an O-ring or a gasket or a complete filter. You just threw reed valves through it, and now you got to change it. So that gives you some diagnostics without even having to open up the separator.
What would you say? We were talking about this on one of the last podcasts, but as far as your experience, what's the differential that you typically see on a brand new coalescing oil separator?
You talk about some compressors that tend to throw a lot of oil. We anticipate that you should see anywhere from maybe 1 to 2 psi differential on startup for clean. And my recommendation is anywhere from 10. I'd say probably 9 to 10 psi. I'd get that thing changed, or you're going to end up with a problem.
Did you? We didn't go over the supermarket application with undersizing them yet.
Yeah, that was the first one we just did. Yep. So
Okay.
So we undersized the separator, and that would have been a 2 1/8 separator. But what we can do, if some people just now join, we can go through it here again. So oil separator sizing calculator on our website. You can just click this button here. So if you're wanting to undersize the separator to cover yourself on low conditions, if you go to click that yes button, and we're going to go with R22, and we'll do number of suction groups 1. We'll do 100-degree condensing or saturated condensing temperature. Your evaporating temperature, we'll do a plus 20 and 350,000 BTUs. When you submit this, this says it's an OS6-21, so this is a 2 1/8 oil separator, and that likely would have been a 2 5/8 based on what I'm seeing here on our selection. So this is what this is doing. It's allowing. Now it's not always going to undersize and force a separator smaller than what if you would have said no here. It's not always going to do that. It's because what's going to happen is it's trying to pick the most optimal size. So if it's on a line on that threshold, it's going to select the size lower. But if it's in between that range, it's not going to force something small to where you're going to have a massive pressure drop calculation.
Now, Adam, what would you say would be like a max pressure drop, like you would advise, like if you were seeing like a drop on there? Like, what to you is excessive?
Well, I guess I wouldn't want to see any more than, I don't know, 10 psi probably. And but again, that's dependent on how often you see your compressor, the number of compressors you're going to have running at any given time, because you're probably going to size this thing for let's say it's got 5 compressors, you're going to size it for 5 because you're going to end up having a problem if you don't. But max on normal situations, I wouldn't probably want to see anything more than 10 psi on there. But it's really energy consumption. You're really not going to see, as long as it's sized within the confines of what we offer. You're not going to see any premature failures. It's really just going to be massive, higher pressure drops across that.
Yeah, I mean, I've seen where we've done glass door conversions, and these were manufacturer size separators, but like it went from a 2 1/8 discharge header with 4 compressors down to 5/8.
Yep, exactly. I've seen them stair stepped to the point where it's like the amount of reducers in those lines is makes you want to vomit.
It's a Christmas tree from 5/8 to 2 1/8. I mean,
exactly.
It blows up to 2 and 5.
Yep, exactly.
You first see it, and it looks insane, but I mean, it works like extreme. Yep. I mean, it was at a point where we were taking I think I took 6 gallons of oil out of the rack.
Yep. Well, and I guess that brings up a good point, and something that I think also needs to be mentioned. So let's say that you got an application where you're let's say that you adopt it. Let's say it's been a problem for somebody else, and you tend to adopt this problem child, and you walk in, and you got all these problems, and you finally get it all worked out. And let's say it's got a coalescing on it. The guy before you likely was dumping gallon after gallon of oil inside that system. Well, once you get everything set properly and you get all that oil out of your evaporator, you got to be very careful to watch your pressure drop on your coalescing filter, because those filters will become oil logged, and it's going to catch that oil once you get it out of the system. And a lot of times, and I think this was actually posted on the Facebook group, a guy had a situation where I think he pulled maybe 8 gallons out of the system, additional gallons, we'll say, out of the system. And he had a filter that literally ripped through the seams of the element itself, because it just was a massive amount of oil that was getting pumped in through that filter. So that's something else that you just, to put in perspective about pressure drop monitoring on a coalescing. Yeah, it catches oil, but it's going to catch a lot of oil if you had a guy that was dumping oil in there, constantly.
Adam, can you, since we're on the top of the coalescence, can you go over your guys' filters and the replacements for the temp rights?
Sure.
Because I know a lot of guys don't know about that, and they've worked out pretty good.
Sure. Yeah. So basically what we did was, our filters are a borosilicate glass, so basically like a fiberglass media on the inside of a wrap. And what we did is we designed filters that were very robust, and let's face it, we've all had our heartburn with gaskets. So what we did here recently is we took our gaskets are slip fit, so there's no adhesive holding the gasket in place, and it actually slips on the inside of the filter. So we have a wide range of filters that now are going to have a slip fit gasket that there's no way that that gasket is going to blow out like an O-ring, or even a gasket that's got adhesive on it. So that's good. It's not going to blow out, and you're not going to end up with failures due to just an O-ring blowout. But that's why once it's torqued, it's going to stay there until that filter goes. So another reason why you got to make sure you monitor the pressure drop across that. And I know guys are going to say, well, I'd much rather have an O-ring blowout and a little bit of a oil low level alarm than have a glass filter media blown out through the separator. And I can't dispute that, but that's why we're offering the new differential monitors, because the filter should be designed to seal regardless. and that you have to have an ability to know when that filter needs to be changed. And so I say all that to say, people came to us and said, we're tired of O-rings on the maroon filters. And so we're tired of this. We're tired of it. We need you guys to come out with a model or a series of these. So we did. And so it's across the line on all the Temporite ones. We're working on some CO2 ones as well. But I think the big thing is, these things fit, and you're not going to have the gasket. And, I think a lot of people have been happy with them. But the big thing is you can't just drop them in and forget about them, because I think you're going to end up with a problem, especially, again, if you're blowing out O-rings and the guy didn't know that really was the problem. He was adding oil, and now your filter is going to seal. It's going to catch that oil. So I think that's but it has worked out really well, and it's offered some good solutions for customers like yourself.
Now, you mentioned the Delta P monitor. That one does work for CO2.
Just
as well
about
as
every
regular
one of
lead.
the racks, we ended up taking at least 2 gallons of oil out. Some of them 4 to 5 gallons of oil, because they kept blowing out filters. I mean, they had other issues too with cycling, but after we stabilized all that, I mean, when we put those new filters in, I mean, we didn't blow a single O-ring after that, and we had no problems with the O-rings blowing out. I mean, They blow out on startup with the Temporites all the time, especially after a power outage and everything comes on. If timers aren't set right and everything comes on, the O-ring's pretty much guaranteed to blow.
Well, that does happen. I mean, I don't know how many guys will call me and say, listen, I get all this pulsation, and you get all these things where and that's the problem is, you're running, maybe 2 compressors, and then all of a sudden you get 3 or 4 that start kicking on, and you get that really slug of mass flow that comes through that, and it'll want to pop those O-rings out.
Hey, Kevin, maybe you know this. Someone was asking, how is the price comparison for the Temporite filter replacement?
They were cheaper. Every model was anywhere from $15 to $30 cheaper, depending on. I mean, we bought them in a mass quantity for PMs. I mean, so they were. We probably got a little bit better price, but they were way cheaper. I mean, we had. All the O-rings were fine. We had no problems with the O-ring fitment on them. I mean, they were pretty much exact fitment filters. Adam, do you know like the design quality? Like, what if? I know I reached out to these before. I don't remember if we ever got. I don't remember what you told me. What is the design, like the micron rating compared to like a Temporite? What it's going to actually filter out compared to Westermeyer?
It's the same micron rating, and I think that, the difference between the construction and what I can do is here I can literally just pull this up while we're chatting about it, because we list it here. But the big thing is if I'm going to go to, bear with me 1 second here. But I mean, the micron rating is down to, I think, 3 micron. Yeah, 0.3 micron oil mist particulates. And the big thing I think that everybody also needs to understand is there's a relationship between pressure drop and efficiency, and that's a fine line. And ours is like a fiberglass, like I said, and I think the Temporite models tend to be a little more like a pleated paper, which are good for capturing particulates, but can also be kind of a problem surrounding pressure drop and blowouts. So it's a fine line.
Now, do you guys offer a cleanup filter like Temporite does, or no?
So we don't, and the reason why is we offer, and I'm actually going to just find the filter sheet here while we're all chatting about it. So this is the spec sheet here that details, and you can pull it up on our website, and it'll have all the models listed here with the crossovers. But we don't offer the cleanup, and the reason why is, one, we have a gasket. So really, if you look at the difference between a Temprite model where it has the O-ring and on a cleanup and a standard filter, you're going to see they have a little more of a recessed area on the inside of that filter. And that's just to help protect that O-ring from blowing out during high differentials. Again, with our gasket, we don't need that. And really with our robust, we've got a really thick material that we wrap on the outside, which is what we call our drain layer and containment layer. So that's going to help hold up against high differentials as well. So in reality, we really don't see the need for the cleanup filters, which is why we just offer the standard filter, which is going to help reduce the number of filters, in my opinion, that you're going to have to carry.
Now, are any of those Temprite filters, any of them cross over to the Westermeyers?
Nope.
Somebody just asked me that.
Nope. And they shouldn't even want to know that. Why would they want to know that? That is bad mojo.
No, I mean like
kidding.
the actual Westermeyer replacements for the Temprites. I mean, will those fit in any Westermeyer separators too?
Oh yeah. I see what you're saying.
Just fit in the Temprites.
Nope. So there's two models here. So we carry two series that we also use in our separators that also is used in the Temprites. If you see here in this category right here. So the 90050 and 51 are part of that.
Okay. Yeah, that makes sense. You want to go over your floats real quick? What we got you on here too? I mean, your guys' floats have a little bit, some different stuff on them too.
Yeah. Yep. So, and I'm gonna quickly blow past that image because this is not how the new float looks. This is the how the current float looks. So what we've done is, if you look at like an ACNR float, it's got it looks like the old ones, like our old ones, where it's got the bend comes up, comes down, and then your float sits on the lever. Well, what we did was we took out all that linkage and all that bend, which is all tolerance buildup. And that's all areas that, if you look at that bend, and I know you guys, do this where you pull it out, and you're not getting oil return, and you'll take that and you'll bend that copper piece back, or you'll bend that float up just to get you a little extra room so it's not hitting on the inside of that shell. Well, what we've done is we took all that linkage out and made it a straight piece, and we got the float up on that arm, and we added a magnet on it just to help try to protect a little bit of debris from entering into that orifice. It was more of a wish list from a couple customers to add that. I question some of the validity on it, but if a little bit helps, then it's worth it. If you see here, we did flow testing across the old design, which is very similar to the ACNR, and this new design, and we flow up to 20% more oil with that with the new float.
Yeah, I noticed on the new floats, when you change them out, if you have an oil cycle glass, it's a lot less foamy and bubbly when it is feeding. It's more of like a solid flow. It looks like a liquid line side glass with that's kind of like low on refrigerant. It has a lot better flow look to it. Like, so you could tell it is flowing better, and it's not restricting it as much, and it's not getting like that foamy type of oil like you get from like an ACNR.
Well, and so to put that in perspective, so if you guys have, because I know that there's tons of guys that have the A1930s on their trucks. This float is cross compatible, so you can put this in an ACNR separator. It's got the same bolt hole pattern, and I will tell you that we've got some that will also fit into maroon ones here coming up soon.
Same design as this one right here, just being able to go into the maroon one, guys?
Correct.
Beautiful. Might as well repaint at the time too.
Yeah.
All right.
Okay,
today. Adam, do you guys? I never really looked. Do you guys actually make oil floats, like actual compressor pots?
We do. So that's a brand new product that's coming out, and we don't even have it on the website yet. But a couple of things that I want to touch base, and what I'll do is I'll go ahead and stop sharing this so everybody doesn't have to see me kind of clicking around here. But let me see if I can figure this out here. So I'm going to stop screen share. So the new regulator floats that we're going to have are the oil pots. We've waited a long time. We do build a fixed level, and we do make a few, but everybody asks us for the adjustable. Trust me, I would like to just completely wipe out an adjustable regulator and have them never exist again. For one main reason is that they tend to be the culprit of all tech calls that we tend to get blamed. It's like, listen, the separator's not working, and you gotta fly out here and fix this problem. And so what happens is the adjustable regulator tends to be the biggest problem with that. So, but reluctantly, so Westermeyer's been in business. This will actually be 20 years this year. And we've reluctantly spent a lot of time, I'd say probably 10 years working on a design that removes all the linkage and removes all, a lot of the fail points on an adjustable regulator. And we call our unibody design. And so that adjustable mechanism in there, it's all one piece now. There's not any of this screw through and pins and all this. We designed it all into one piece. And the adjustment mechanism is actually on the top of the stem, so it's a 90 degree. But what we do is we offer a Roto-Lock valve that's bi-directional, so it's a front seating or back seating Roto-Lock valve, and you can swivel that 360 degrees. So if you're doing a retrofit and you need to be able to find a point at which that you can make a connection, you can swivel that valve all the way around to help for install. And again, now the mechanism for adjustment is all on top. It's not on the side next to the actual stem itself. So because as we all know, those are in really tight areas, and so if you got to try to get in and adjust that, we're also going to get rid of that the screwdriver portion, because everybody just really they round those off, or they over adjust them and they come out, or they over adjust and the C clip pops out. So all those things we're addressing, so those types of things can't happen.
I never really thought about like all the people that must call you guys for oil issues. I just, I don't know. I don't think I've ever called a Westermeyer or anything unless I had like a sizing issue for something. But like, I wouldn't think anyone would actually call you guys. I got an oil pot that I don't think's feeding. I'm sorry. I never seen that.
Yeah. Well, because what happens is like, listen, I'm tripping on low oil. I've got oil sitting in these sight glasses on these oil pots. It's got to be the separator. You got to fly out here and start coming up with solutions. And so what happens, again, oil gets lost out in the system. Then you end up with this problem. It's like, listen, that separator's failing. And we even get it with coalescing. We had a really bad situation where coalescing separator it's big. It's 3 1/8 coalescing separator, and on a brand new store. And we ended up with a situation. We were out there for a couple days. Gary Westermeyer actually went out there and was troubleshooting it, and come to find out, we anticipated that it appeared that the discharge temperatures may have been way too high and it was vaporizing the oil. That's where we were getting at, to the point. And it come to find out that the installing contractor like mixed his own oil. It wasn't even like the author. They finally did an oil test, and they were mixing. They were like 3 parts different oil composition, and it was, and it wasn't, the viscosity wasn't flowing through the system. So it was, it got to be really kind of a big mess, but we finally got through that one. So yeah, you'd be surprised on the stuff that we get wrangled up with.
That's amazing.
Wow.
Well, if do you have any new products in the works?
Well, I mean, there's a lot of top secret stuff that I'd have to kill you if I told you. But the big thing is the oil regulators are a big one. We're making a big push on the inline oil filters. Kevin mentioned those on the last podcast. One thing I do want to point out on that is be very careful on your OF 303s where it's got that bypass. Kevin, I think you said that you try to not have the bypass, which I commend you for, because let's face it, if you're offering a bypass, then why are you even putting a filter in? But because also pressure drop and the location of a filter, one thing that I want to mention to everybody is, and this is taking a lot of education at the rack level, because let's face it, you guys it shows up this way, but we always recommend the oil filter to be between the separator and the reservoir, but that's not how most of them are done. And the big thing is pressure drop. So when you start getting a dirty filter, what's going to happen on low pressure systems? What's going to happen with that pressure drop in relation to in relation to suction? You start causing some issues with oil return if your filter gets clogged, and then let's face it, if you got a filter that's got a bypass, then again you might as well just not even have it in there.
Yeah, because let's just say you have a 5-pound differential across it, and it's in line with the coming out of the separator. You got discharge pressure coming out, so that only drops at 5 pounds. But if you have it on the outlet, where it's going to be regulated down, then 5 pounds could be detrimental to the possibility of feeding and not feeding. Correct.
Well, and here's the other thing: if it is on the inlet to the reservoir from the separator, think about it. If the float is full of oil and it's pushing pressure on the one side of the filter, you're always going to have a measurable pressure drop on it. If it's on the other side, if you have no oil floats calling for oil, you're going to have zero pressure drop. So a guy's going to go there and measure the pressure drop across the oil filter. Unless you have compressor floats calling for oil, you're not going to have a pressure drop.
Right.
Why do manufacturers put it on the outlet then?
Because the gray company tells them to do so.
Oh, gotcha.
So that's an education that we're working on, and one of which is just trying to get people to take the new one on. There's a lot historically, people just don't understand how challenging the ROF 413 is to service. When you twist those flare connections and that copper twist, and then you got leaks, and then you got multiple connections because you have the brass to that aluminum cap, and then you got to pull that whole can away if that's ultimately your choice, which is probably the best solution, is not try to unscrew the flares and actually just pull the can away. But then that can tend to be a bit messy if you're not careful.
Well, you guys also make a can filter also, right? I don't know if it's out yet. I know you sent me one and I put it in. Yeah. It is. Yep, I mean that one was a lot easier because you could just pull the cap off the top, and there was no connection on it where you had to pull anything off.
Well, and actually, why don't I just pull that up here while we're talking here? So, Brett, make sure you give me access to do that. Don't try to lock me out again. All right. Everybody see that?
Yes, sir.
All right. So if you look at these oil filters, this is this serviceable oil filters. So if you look, and we offer this both in Roto-Lock or sweat. So, I mean, for sweat, if you just don't want the leaks, that's the benefit here. Roto-Lock, you have the ability to isolate it, but it can be mounted vertically like it's shown here, or it can be mounted horizontally like a dryer that's shown here. But, as Kevin mentioned the other day, the connections are no longer in the flange. They're all in access here on the shell. And then you also have an access fitting here. Also, what you can do is we've tapped this flange So if you look at the spoolment today, you have to compress the filter, then you have to run the bolts in, and they've got the square nuts on the bottom side, run them in, get everything sealed up. All the while those connections are off the top here. Again, whereas this, you could lay this on its side and service everything horizontally like a dryer.
Something I forgot to ask you. You guys don't make a replacement for the gray company, do you?
You mean like an actual filter element itself?
Yes.
Nope, we don't. Really the intent is just we're trying to eliminate all these problems, and we hate to really kind of hitch on something that really just needs to be fixed in the industry. So, and we were asked by several companies to get into it, and it's just we're just trying to get everybody kind of hooked up to it at this point. Really the other thing we're doing, and I literally just clicked off this and I didn't mean to, and I apologize for that. The share screen, I'm gonna share with everybody one more product here, and what it is, it's a liquid level gauge, and I think some people are starting to use it in the industry. But what this is, this kind of competes with the 4-bolt level gauges that are out there that go on the side of the receivers. So your liquid level gauges. So the company that manufactures it is a company called Rochester Gauge. So if you look here, and in fact, I'll pull up another sheet here in a second, but basically what you see is, so this, we offered in an OEM level, which is where we actually put an 1 3/4 Roto-Lock connection on there. And we also offer it in a 4-bolt retrofit kit as well. This is actually a sight glass. This electronic piece snaps onto a sight glass. So you'll get 50% level indication here. So you'll at least know, are you above 50% or below 50% to determine whether or not that level is actually accurate. It provides an output voltage you can tie back to your controller at a 0 to 5 range. And it's got a digital readout display. And, if the electronics ever fail, you can just pop that off the sight glass, put a new one on without having to pump the system down. And really the big thing that everybody really likes is that with this 4-bolt, this thing tends to leak. And actually, in our market research, that is actually one of the highest leak points on a supermarket rack. The amount of gaskets for just the 4 bolts alone that we sell are just astronomical. So what we did with this product line is, with the retrofit kit, we developed a different gasket material, and we also do an encapsulation key on the back of this. Kind of looks like a record grooves, and it holds that gasket in place. And that gasket that we put in there, it's actually it's kind of like a Teflon type gasket, because today it's used neoprene, and that tends to, especially with retrofits and stuff, they tend to leak over time. So that's another new product we're trying to get out in the market as well.
Now, Adam, do you guys sell that gasket for the standard 4 bolts for like a Rochester? Yep. So you guys sell that different type of gasket?
We do.
Really? Do you have a part number on it?
Yeah. So are you talking just the gasket that you can replace on the Rochester, or do you want the new gasket?
Like the new gasket, like the one you guys are putting in, that one.
I see
will it work or no?
Yeah. So it won't snap on the backside of that on the backside of the Rochester gauge, unfortunately. It's funny, I've been asked that question a couple times. They're like, well, can I just get your new gasket? But again, that's the other thing is with those 4 bolts is you have to torque them equally on all 4 corners to also get a good seal. And that's the benefit with ours too, is that it's a Roto-Lock connection. So there's no tightening of one side. It's basically just spin the nut on and torque it.
Yeah,
I don't think I've ever replaced all the Hansen rods that we usually deal with usually have the Roto-Lock fittings, and I can count on one hand how many times I've had to replace it versus how many times we've had to replace that 4-bolt rubber gasket, whether it be poor installation or not torqued properly or whatever. pulsation, whether it be, hot gas, receiver pressurization valve, feeding hot gas in there.
Yep.
Whatever might have caused it,
Exactly. And we have we have the electronic version, but we also have a dial set as well, where it has just a needle and a level showing on that. So you don't have to have a full electronic model. You can also just add the mechanical one as well.
Do you guys make Hansen rod replacements also, right?
Yeah, we do. Yep. Exactly. Yeah. So, and we calibrate them. They're factory calibrated to the refrigerant that you of your choosing, and all we need is the length and the refrigerant, and whether you not want a Roto-Lock or NPT style connection on the receiver, and whether you want a display or no display. But yep, we offer them and they're pre-calibrated.
And you guys make custom lengths, right?
Yep, exactly. Yep. So we'll do 10, 11, 12, whatever. We can't do we don't do half length. So we'll just, if you're like, I'm measuring and it needs to be 11.5, we would just go to 10.
So we had a run of Bullseye stores where basically they had 60-inch receivers, but they had 54-inch
probes.
Yeah, probes in there.
Yep.
So every single time it would get down to 20%, it would read 0, and it was just confusing because we just kept kind of calibrated and it didn't make any sense. And it wasn't until we actually measured the receiver versus what probe was in there, finding out that it's 6 inches smaller than what it needed to be.
Right. And one thing that happens, a lot of manufacturers do this. So they'll put the probe's not directly on top. Usually the relief valve is directly in the center on top of the vertical receiver. And they'll put that connection for the probe offset. Well, if you think about, the head comes up as it gets closer to the outside of the tank, so they can't put a probe at the full length of the tank. So there is a little bit of math that kind of comes into that, that you have to actually have a shorter length. That happens a lot.
Now, Adam, do you guys list these for CO2 also, or just standard refrigerant?
To be continued on that, Kevin, with CO2. You can use these for subcritical CO2 because they're good up to 1,000 psi on the for the Roto-Lock model, but to be continued on the CO2 transcritical versions.
So we should be good with that on the CO2 receiver then, because I mean we're looking max pressure 525. So I mean that would be perfect then.
Unless you have a failure.
Yeah, failure. That's the concern that everybody gets. That overpressure gets everybody. That makes their buttholes pucker. They're a bit.
Yeah, I mean, but there's so many reliefs on there that those are going to go way before that is.
Make the push, man. We'll let it rip. I just know that there's a lot of that would not that would be a hard sell to a lot of people. So, but we've got the platform now, so let's just make it happen.
Yeah, I mean, because we've had a lot of right now we're using a lot of level switches, and I mean, to be honest, like HEB level switches, and I'm very disappointed with them. I mean, they have a very high failure rate, so I would much rather see like a Hansen probe like this in a stand-up receiver than HEB switches.
Right. Yeah. Well, and I can tell you that it's a big push right now for those. So again, that's the type of stuff that you're going to continue to ask me about this, and probably about half the things you're going to ask me for. I'm going to have to say, listen, Kevin, I can't speak any further about this, or I'd have to kill you. You're just going to keep squeezing me for stuff, because we do have a lot of new things in the works. I would say we'll probably have another 10 new products launched probably between now and next year.
All right. Well, before you start killing Kevin, is there anything else you wanted to bring up while we're on here, boss?
No, I mean, I think you guys have really brought a good thing to this industry, and I appreciate the opportunity coming on and chatting a little bit. And And hopefully, this adds a lot of value to everybody that was able to watch tonight. So, but I appreciate what you guys are doing. It's going to make all of us better, and it's going to make maybe our lives a little bit better across the board.
One last question came up real quick. They were asking if the display was weather tight.
Display needs to be. There's an RTV that you can get to fill that cavity if you want a watertight enclosure. Unfortunately, but more to come on that. It's not a good solution. I understand. I hear everybody loud and clear on that, but we can offer it's basically like a silicone that you can fill that cavity with.
All right. Well, listen, Adam, I appreciate you coming on.
Yep, really appreciate it.
All right, guys. Have a good night.
See ya.
Bye-bye.
Night.
Bye.
Bye.